Awesome. Well, I really appreciate everybody joining us this morning. Super exciting workshop to get underway. We've got Radha here from the Web3 Foundation, works close with Parity, Polkadot, and Sophie as well. Gonna kick it over to y'all to make a quick introduction, but any questions that do pop up through the workshop, please post them either in the Discord server or in the chat channel here, and we'll make sure to answer those questions at the end. But I'll let you kick it off, Radha.
Yep, thank you. Yeah, so I'm excited today to, first of all, like I'm whatever you're doing at Web3athon is really close to like my heart in a way, being able to use technology, for the common good. Actually, Polkadot aligns with that as well. I'm going to get to that at the end. But yeah, so I'm going to show, so given like building a blockchain itself is like a very heavy task. I'm going to show like how Polkadot ecosystem lets you build customized blockchains, for the use cases that you might come up with, that can actually evolve with time, So we're going to go deeper into the topics of like forking and how like Polkadot sort of enables forkless upgrades with whatever improvements you make to your blockchain later. So let's get started. Let's see if this button works. There you go. So almost all the chains in Polkadot ecosystem, so they are Substrate based. So Substrate is a modular, flexible, and extensible framework for building blockchains. So modular meaning, I'm going to show in a bit in today's workshop that we have plenty of like modules, what we call like palettes. So you could actually, mainly for blockchain development, but the whole substrate itself is sort of modular. But yeah, so you have these Lego style blocks that are out there that you could use when you're developing like blockchains. And these blocks are flexible. Like you can make changes in them to, to whatever extent you would like to, and customize them further. And also extensible, meaning you can also build like your own modules, out there, and then have blockchain development rolling. So what I'd like to highlight here is that you can reuse the battle-tested libraries that are built by the core developers at like Parity and like the Polkadot ecosystem. All of these libraries have been tested out there in the real world, and people are using it, and they're out there at your disposal. So the key set of libraries that I want to like point out are referred to as Frame. So yeah, it's a framework for runtime aggregation of modularized entities. Point being, like, this is like the brains of your blockchain. So this is where like customization happens. Like you have the state transition function in your blockchain, and you can get started like right off the bat with the Frame palettes. Palettes is what we call them. So palettes are out there at your disposal. You can use them and then start a blockchain and start hacking it. So in terms of assuming like some of you are developers who are attending this talk, in terms of like technical freedom, you can go all the way to the core primitives of Substrate itself. But usually, like if you're not familiar with like Substrate at all, we introduce Substrate with like a template node. It's like a blockchain template node. Once you sort of compile it and sort of run it, it actually starts a blockchain. Okay, so that's where people usually start, and then they start exploring Substrate Frame, which lets you add like cool features, to that particular blockchain. And then if you're not satisfied with like what Substrate is offering, there is the flexibility for you to even like change the core primitives of it. Substrate is based on Rust, so Rust is a programming language. Yeah, so typically the Frame palettes, they sort of look like this. So grandpa is like a finality, finality gadget that is readily supplied for you. So if you can use that as your consensus. And yeah, so you have like balances palette, democracy palette, EVM palette, multi-sig palette. So all of these are available at your disposal. So you can create a runtime with whatever is out there, just like you're placing these Lego bricks together to create like your own masterpiece. So that's how like Substrate developers, the ones who are developing Substrate, so they envision like blockchain development to be of this sort. And I'm not exaggerating when I say like, it's just like a drag and drop. We're actually going to see how to use like a palette that is already existing into the runtime of your blockchain. Yeah, so what we're going to do is we'll take a brief look at like what a Substrate node comprises of. We'll dive into like Substrate template node, the one that I mentioned about. Yeah, a brief walkthrough of a Substrate palette, what it contains, and then finally innovating with Frame, right? So that's what is the theme of the hackathon that you're having. You'd like to innovate, you have like these new ideas, you want to make use of the existing code base to be able to realize the idea that you have. Let's see how you can innovate with the libraries that Substrate already has. All right, so to begin with, like networking aspect of Substrate nodes, so we use like lib peer-to-peer, like so Substrate developers haven't developed their own like networking stack, so we use lib peer-to-peer stack for networking. So WebAssembly, it's the key technology that powers like Substrate nodes. So everything in the runtime, it's compiled to like WebAssembly. So that WebAssembly has all the state transition functions in it, and then it sort of the WebAssembly is like the brains of the shell of the brain, basically, in like Substrate node. And then Grandpa, so if you're thinking about like finality, like Cosmos like offers like its own finality gadget or whatever. So Polkadot and Substrate, so they ship with like Grandpa, so that's like the finality gadget. So you need not be worried about like block finalization. Typically, if you looked at the Polkadot blockchain, the blocks get finalized like about like 20 seconds on an average. So if you look at the best block and the finalized block, they lag by like 3 blocks. So each block is produced in 6 seconds. But again, like if you are dealing with Substrate node, you have the ability to sort of customize the block times as well. And depending upon your use case, depending on whether you're trying to plug it in as a parachain on Polkadot or have like a standalone chain, you can customize the block times as well. Okay, so Substrate template node. So I just shared, I think, yeah. So I shared like a link earlier in the chat. I would ask, someone who already has it to reshare it for the participants. So the Substrate template node, you can actually download that from GitHub repository, or we have it in what we call like Playground. So we're gonna pause the presentation here and then go to the Playground and play around with it and see like how to add a palette to the runtime of the blockchain in a bit. But yeah, so playground.substrate.dev. So if you have a GitHub account, I would request you to sort of click on it. So for now, I'm going to stop sharing this screen, and then I will share my browser. Okay, so where am I? Windows. Okay, so let me share the whole screen. Here. Yeah, so typically if you have like the Substrate Playground open, like after you log in, this is what you would see. I'm going to go ahead and sort of create like a new session. And yeah, so I personally requested for this to scale for like 10 people. Let's see how this supports me for now. So what we're gonna look at meanwhile is the other resource that we'll be leading. It's docs Substrate. Okay, so I'll be pasting this link as well in the chat. So we're gonna run the adding a palette to the runtime. So this tutorial as a part of today's workshop. So let me do that. Chat. All right, so let's see. Yeah, this always happens when I try to do something in live, but yeah, so thankfully it loaded. All right. So once you compile like a Substrate node on your command prompt, or if you're successfully opening like the Substrate playground, you should be able to, access like the latest Substrate template node right here, the code. So the key thing I want to highlight is, let me close this. But before I just, go on, how is the screen resolution? Are you able to see like what I'm presenting, or is it too blurry?
It's good.
It's pretty good. Okay. Cool. So yeah, you have a Substrate template node. It has like, all these particular folders, particularly the one that, we would be interested in right now is the runtime, right? So runtime is where like the blockchain's brains are. So in here, like we have a cargo terminal file. So for those of you who are familiar with like Rust, so this sort of handles all the dependencies. And then we have lib.rs, that's the main file that contains all the code that puts the runtime together. So let's go to the cargo file. And if you, let me see the chat. Yeah, so the workshop is being recorded, so it'll be available for you. But in any case, so if you see like my screen, the blockchain is actually already started. So I'm producing the 13th block. If you're already on the playground, so go to playground and click on open Polkadot.js apps. So this is actually like the Polkadot.js that is connecting to the node that I'm running in the playground. So that's actually quite convenient if you just want to like see the blockchain in action in a better way. All right, so as you can see, I'm producing like the 18th block right now, which is exactly what's happening in the substrate playground as well. So whatever you have here is being reflected in there. So you can actually explore what this Substrate node already contains. So you could go to developer tab. Let me go like and see like all the extrinsics. So extrinsics are the calls that you can make to the runtime of a blockchain. So let me see like what are all the calls that I can make, and what are all the palettes it already has. So as you can see, it already has like balances palette, meaning there are accounts, there are like some, each account has a certain like balance initialized with like the Genesis block. Yeah, so there's grandpa for finality, there's pseudo palette, that gives you access to modify things as on the fly, and so on and so forth. So what we're going to do is, so this is like the very basic template that is shipped with like the Substrate template node. We're going to add like a new palette to it. Okay. So like I mentioned, there are already accounts in here. So the new palette, which is named as a Nix palette. So Nix stands for like the nicknames. So we have these names that are already included in the Genesis. I'm going to show that in a bit, like where where all of these are initialized with like these balances. So the next palette is going to create a nickname for these accounts. Okay, so let's see how to do that. And the link for that is in here. You can, read through this particular like documentation, very informative. But for now, we're just going to like execute what is in there, the key parts of it. So the first thing is, like I mentioned, you have to take care of the dependencies. Let's try to import like the next palette into like our runtime. So all you have to do is copy this particular code that you have. So, so we're going to import like palette next into it. Gonna go there. And in the cargo terminal file, so you see palette aura, palette balances, palette grandpa, all of these were like imported in a similar fashion. So I'm just going to add palette next right there. Okay, so let's hope it got copied. Yeah, there you go. So there's a version tag. By default, we're the default features are set to false. The explanation for that is in the doc. It has to do with like, being able to compile it to like a WASM blob. So initially you set the default features to false. Now you have the Git repository, and then you have the branch. Okay, so everything like matches. So what we're going to do is we have to enable these standard features like later on here. So let's try to enable them right here. Just add like the additional code and Control S. So everything is good. I'm just going to stop the blockchain for now. So now we added a bunch of like dependencies to our runtime. One quick way is to like go and check whether everything is proper or not. So basically we did this, and then we added next right there. So we're going to ask Rust if cargo check like whether everything is doing well. So I stopped the blockchain, so this wouldn't work. All right, so let's go here. All right, so now it's going to check, like we introduced a bunch of so dependencies in there, so it's going to check like everything works. And yeah, so I'll let it do its work, and then we can come back to we can come back to this like later on. I'm going to show the lib.rs file in detail before we make any further changes. But yeah, so take a look at this. This is where the runtime is being compiled together. So you have the code. This is out of the scope for today's like workshop, but I'm going to go to the location where we're going to add the next palette in here. So let's see. So we have, we have palette grandpa. I'm going to go to palette balances. Okay. Yeah. So palette balances. So it's a palette. It is defined. So all of these palettes are available in the Substrate GitHub repo. Basically here, you're just going to, initialize them with like few values, or, you mentioned what data type those should take. So Substrate makes no assumptions for, what kind of data types you want to use, or even like the cryptography that you're planning to use. So everything is sort of as an interface, and then you can make changes as you like. So existential deposit. So this is something, that makes like Substrate based chains, like they have a state, like they keep track of all the balances of all the active accounts on the blockchain. So so to retain that information, to avoid like spamming, you have this existential deposit. So this is the minimum deposit that is required for the Substrate based chain to keep your account active. So any balance below this amount is going to be like dusted. And yeah, so you're actually setting it so to a constant of that type, of this value or whatever. So what we are going to do is we'll have, yeah, so everything compiled well. Okay, so there were no issues. Now what I'm going to do is similar to this palette balances, I have palette nicks, and that nicknames palette sort of, you know, requires few things to be set, and those will be set here. So what I'm going to do is I'll go back, going to, yeah, so basically I just showed you, you know, the balances palette, you know, how you set things there. So I'm going to have like the next palette. So I'm going to copy this, and then I will go back and then have, just copy it right here. Okay, so briefly, I'll mention like what I did. So again, like the currency, we're not using anything different. It's the balances. So to reserve like a nickname, it's also a costly operation because the blockchain state is going to keep track of this. Like it's going to match the account with this nickname. So for that, we're going to ask for some balance, which is this much. And then we have minimum length of the nickname. Okay, so we want it to be at least of 8 letters, and then the maximum length is like 32 letters, and that's it. So these are the only ones that were required. And then if you're following the tutorial, it will ask you to go to the construct runtime macro. So this is where it is composing all of these palettes together. So here, right after like balances, I'm just going to add, let me get that code from the document. Yep, nicks and palette nicks. And that's it. So I just demonstrated to you, you know, how you add a new palette to Substrate runtime. So what I'm going to do is I'll save this, and that's all. Like we added a palette, and then now we are going to just build this. So I'm skipping this step for the interest of time. So instead of a release, I'm just going to just build it. It's gonna take some time, but yeah. So this pretty much shows like how easy it is for you to like integrate like a palette into runtime. So I let it do its work, and then what I'm going to do is I'll go back to the presentation, and I'll come back to this. Once it is compiled, I'll show you how to set like nicknames on like the Substrate chain. All right, so where are we? Show. Yeah, so basically a Substrate palette, if you look at the palette definition itself, you have like a bunch of imports or dependencies. So this is of your interest if you're trying to build a palette on your own or write a palette on your own. Yeah, so there is runtime configuration trait, so and then runtime storage and runtime events, like and hooks, like if you want, you know, something to be executed in some context of like the blockchain execution. And then finally the extrinsics. So the extrinsics is what we saw in the developer tab. So these are the calls that you can make to this particular palette on Substrate. So pretty much like we did this, you know, so adding a palette to Substrate blockchain runtime, which is what we did just now. If it is successful, you would see this nicks being listed in that you know, extrinsics tab. So if you go to developer extrinsics, you'll see a new palette listed. And then for that palette, you have like a bunch of calls that you already defined. So next palette already has a bunch of calls that you can make. One is like set name, clear name, kill name, so on and so forth. So all of those will be exposed once we include that particular palette. So in a way, like innovating with Frame, like I mentioned, you know, so we are right here. So all the Frame libraries, so they have like a Frame, you know, they start with like Frame. If you're looking at like the client or the node libraries, they have like C. means client, so Substrate client, and it has like transaction pool, executor, CLI, whatever. And then the core primitives. So they are all named with like SP, so Substrate primitives. So you have runtime, RPC core, etc., or whatever. So, and then finally, like the palettes. So these are the palettes that you can sort of develop and then sort of deploy into Substrate. And I hope that gives you a good insight into like what just happened here. As a developer, you have a lot of technical freedom. If you're just getting started with like developing on Substrate, you start with like the Substrate node, go over all the tutorials that are mentioned out there, and then finish them. So let's talk about like what Polkadot is, because so ultimately you want your blockchain to be secured, right? So right from the beginning, you create a blockchain, you want that to have like a solid security so that people can actually use your applications or build on top of your blockchain. So Polkadot actually does that. So by definition, Polkadot is a heterogeneous multi-chain, meaning, so if you think of this as Polkadot, every single block that you see here is actually a parachain. A parachain is like a parallel blockchain that is running in parallel with Polkadot. And each parachain is heterogeneous in a way, like each parachain can have its own state transition logic. Polkadot doesn't say, you do this, you do that. So a parachain can have any sort of state transition logic. For instance, the project that you're planning to do, so it can have its own state transition logic. Polkadot only requests the blocks of these parachains, so they're produced, and for securing those blocks, so you send them to Polkadot, and Polkadot actually provides this pooled security, as well as it will let you like talk to other blockchains that are already are parachains on Polkadot. So the point being heterogeneous, right? So one of these parachains could be your blockchains. A brief overview of the architecture. So Polkadot is like a layer 0 blockchain. So being a layer 0 blockchain, it can host like layer 1 blockchains right here. All of these are like parachains. So parachains will have their own nodes. So they're not going to be like validators, like what we have on Polkadot. So they're called collators. So collators' the job of collators is to collect all the transactions, everything, the activity that happened on the parachain, package it into a proof of validity block, which can be validated by the validators on Polkadot. So the beauty of this is, so parachains are a blockchain as well. Polkadot is a blockchain as well. So the point being, not all the data of parachains get stored on Polkadot. So the proof of validity block is sent by the collator. It is validated by the Polkadot validator using the state transition function that is provided by the parachain. Meaning, it's almost like think of this as a nation state where it has a constitution. It has how would I put it? It has a bunch of events that have happened, and you're giving this data to someone else to validate it. Does everything adhere to that particular constitution or law? So validators are agnostic to that constitution, that law. So parachain defines those laws, and it says these are the transactions that happen, and it's the Polkadot validators that sort of ensure that the laws have been followed. And if they are followed, so the block is clean, and a certificate, a candidate receipt of that particular block is included in Polkadot. So that's how basically Polkadot achieves its sharding out there. So if you look at the code base of Polkadot, it's it's all Substrate in a way, and there's like tiny bit which is like very Polkadot specific, but most of the palettes that Polkadot uses, they're all shipped with like Substrate, and Substrate has even more than what Polkadot can offer. A simple example is Polkadot doesn't have any smart contracts. It is by design. Being a layer 0 blockchain, it doesn't need smart contracts. smart contracts can find their home on layer 1, blockchains which are parachains on Polkadot. So Substrate actually has a library called as Ink. So if you're someone really interested in smart contracts and you're trying to expand beyond like EVM, check out like the WebAssembly powered like Ink library on Substrate. So yeah, Substrate has all these extra palettes which are not used by Polkadot, but a parachain can actually use them and then be deployed on top of Polkadot. See how we're doing with time. Yeah, so there are lots of interesting features about Polkadot. Connecting networks together. That's the basic use case here. Interoperability, handling traffic at scale. I think Polkadot can sustain around 1,500 transactions per second or something like that, or per block. And yeah, so this, after several optimizations, it can scale to assist like all the parachains doing their work. Security, in terms of like security, it's secured by nominated proof of staking, and Polkadot has like one of the sophisticated nominated proof of staking algorithm that is out there, which sort of enables like proportionally justified representation, which is sort of missing in other ecosystems. Enabling custom-made platforms built, this is what Substrate does. Even governance is like very unique in Polkadot. As I think just before having this talk, I think Gavin would sort of publish this governance V2 article on Polkadot Network blog. So if you're interested in governance aspect of it, check that out. And the thing that I'm very interested in, and I find like very interesting, is the self upgrades, or forkless upgrades. So let's see how they happen and why they're important for you as a blockchain developer. So you need not finish a blockchain in full to deploy it. So you can deploy your blockchain like this, and then over time you can upgrade it to this. Okay, so in this upgrade path, you won't see any hard forks, because by design, like Substrate based chains and Polkadot, they support forkless upgrades, meaning the code, the state transition function, the runtime that we actually compiled earlier in the workshop, that sits as like a WASM blob within the block itself. So the block, every Polkadot block has the code as well, along with the state. There's a state transition function is also part of this block. Over time, like people say, okay, Polkadot needs an upgrade, so let's change the number of validators from 297 to 1,000, and they make that change. The code is actually uploaded to the blockchain through on-chain governance. People actually vote on it. So whatever conflicts you have, you resolve them as part of on-chain governance. It's not like the software has to be downloaded by every other node that is running like Polkadot. So the blockchain itself contains that code, and the set code, call is going to change that particular parameter or the code itself. And from the next block, the validator who's producing the next block is going to use the updated code to produce a new block. So this is a very cool feature. So it's also available as like a tutorial on like Substrate docs, making like a forkless upgrade, like, on a blockchain without having to download new software. So this is pretty cool. This lets you like start with a blockchain, deploy it, distribute it, and then focus on like improving its aspects through governance. So if you are like the sudo, like you're the administrator of that blockchain, you can do this like through a switch of button. But if you're decentralized, you can enable this through governance. But in any case, you won't have the issue of hard forks. Yeah, so like I mentioned, it's the fifth or probably sixth tutorial in getting started. So you could actually upgrade a running network. So blocks are being produced, you deploy an upgrade, and the upgrade shows up in the runtime of the blockchain. So something to to take an idea from, or something to build on top of. There are plenty of projects out there for all of these use cases. I would encourage you to take a look at all of them, or some of them that make sense to you, that are relevant to the blockchain that you're building. Yeah, so I think most of you are focusing on this aspect, the social impact and humanitarian. So take a look at the existing projects on Polkadot ecosystem. So in the interest of time, I'll skip I wanted to talk about the network itself. I don't think that's very relevant here. Yeah, so we have nodes everywhere. It's kind of decentralized in a way. Parachains functionality got deployed last year. Polkadot now has over 20 parachains. There could be more. This slide is slightly out of date. And then I should also highlight the role of Kusama in the whole Polkadot ecosystem. So Kusama is not a test network, it's a canary network. It also has a lot of, its code base is basically Polkadot, the advanced version of Polkadot. So all the changes to Polkadot are deployed on Kusama first, and you check whether everything is working well, and only then you push those changes into Polkadot relay chain. One example that I can give is if you're familiar with staking on Polkadot, there's a new feature called bags list. It enables people to participate in nomination pools. It's a better way of sorting semi-sorted list of nominators. So all of those features were deployed on Kusama first. They've been checked for bugs, and then only when they're better, they move to Polkadot. So clearly Kusama has more parachains because it started much earlier. Even parachains functionality has been enabled on Kusama much earlier, and so on and so forth. So there are more parachains there. So if you're an enterprise blockchain and you can't afford to make any mistakes, so you'd be looking at deploying a parachain on Kusama first, ensure it's working well in a real world economic situation, and you have a counterpart on Polkadot as well. So a lot of these parachains here have a counterpart on Polkadot as well. Yeah, so I would say if you want to get started, you can pick any of the projects that have already been developed using Substrate. So most of them have their repo with public access. There's Web3 Foundation grants page, which has multiple aspects of these projects that are public and are available for you to build on top of. So take a look at them and they'll be useful. And I would say build a common good parachain. So let me highlight something here. So StateMine and Ncointer network, these are common good parachains. Particularly Ncointer is for social common good. They do something called as proof of personhood. So Polkadot ecosystem in general is very welcoming to common good parachains in general. So one good thing about these is they don't require to win a parachain slot auction. Through the governance, they can be onboarded as a parachain, as a common good parachain, which is useful for the ecosystem, which is useful for the world in general. So that's something that you can focus on as well, and make a governance proposal to make your blockchain as a common good parachain. Yep, so that is my details. It's being recorded. But anyways, before we hop off, I want to show the next palette in action. So let's do that here. Okay, so we have this. I'm going to, yeah, so this, I just have to run this blockchain. What's the command? Just a second. So we have this, he built it. Let's see. Yeah, I removed the release tag, so I don't know if this is gonna work, but we'll try. What's going on? Yeah, that's bad. Where did it get built? Yeah, so basically, so I don't want to take your time here, but let's see. Should have just let it be. This is this target. I think it's in. Yeah, at this point, I'm sort of open to questions. Happy to take some questions. I think it's in debug.
And I'm sure a lot of questions will come up when people rewatch the workshop as well.
Yeah. Yeah. Sorry for ruining this. But yeah, so let's see which one. Yeah, I see it here. Let's target debug. So the point being, like so I've compiled the node, and so once it sort of starts, you go to like the playground, you open Polkadot.js apps, and once you connect to the blockchain, you're gonna see like the next palette in action. So that's sort of concludes the talk. So let's go there. I see some questions in chat. Yeah, so so parathreads are not like a implementation in production yet. So they are still an idea. So right now we just have like parachains. The whole pay as you go like subscription model for parathreads has not been implemented on Polkadot or Kusama yet. So that's still in the timeline. So what they let you do is if your blockchain does not need like a continuous access to the relay chain. So let's say you're someone doing something with like how would I put it, like land registrations, like they don't happen like every 6 seconds or 12 seconds or so. So if you want to submit a block only when there are enough transactions in it, so you could become like a para thread instead of having a parachain and then constantly like adding blocks to the blockchain, increasing like the storage space for your collators and your nodes. So you can wisely build the blockchain using a para thread. So I hope that gives you a sense of like the use case for para threads and in terms of like implementation. So there are few things that are still being like ironed out. They want this to be so we don't want that to like sort of be some sort of so the quality of experience of parathreads is like of very importance. We don't want people to be able to stop you from accessing the relay chain when you want it, so when you auction for a block space, then you're pitching like multiple players against each other. So the whole tokenomics for that needs to be figured out. So that's why they haven't been deployed yet. Yeah, I think I'll take a leave. And the number of parachain slots. Yeah, so the number right now that we have is 100. So that's just a hypothetical number based on like what tests we have run in the test nets. So we don't know like how many parachains can be supported yet. Okay, so it could be 150 or more. So Kusama is the one that's sort of testing the limits in production. So the parachains slots, like so we still have like plenty like open out there, and then if they were to get sort of clogged, then we have plans to scale the relay chain architecture. So there is the concept of a relay chain on top of a relay chain, scaling it sort of even further, with what we call like nested relay chains. But we are still not there yet. So there are a lot of optimizations happening on itself. So yeah. So the economics of launching a parachain, if you take a look at like the auctions that are happening on Kusama and Polkadot, especially with the market conditions right now, it's not much. So you can raise the capital through like what we call crowd loans, like people actually contribute tokens on your behalf for you to get like the slot. So those tokens are bonded on your behalf till the slot duration, and then they're permissionlessly returned back to the user. So it's very possible for you to go to an open auction. But again, like I mentioned, if you're building something of common good, you can also deploy like a common good parachain via governance, and it doesn't even require like an auction to happen. Yeah, parathreads are well in like by the end of this year. So there are two priorities. One is bridging Polkadot with Kusama. The other one is like parathreads. So both of these are like high priority tasks for the developers right now. All right, thank you. I'm going to try one last time in the playground and then sort of end today's like talk. Yeah, I also think I should have. So when I run this, I should enable like this external thing as well. Let's see. Okay, so I don't think I'm lucky today to show you like how Nextpalette works, but yeah, follow the tutorial. It should be pretty straightforward, and then you should be able to like add nicknames to those accounts. All right, so with that, I'm going to end today's talk. Feel free to reach out to us if you have any questions regarding the workshop. Thank you.
Really appreciate it, Radha. That was awesome. Definitely super insightful. And again, sorry to sound like a broken record. I'm sure a ton of questions will pop up once we post this back into the Discord and into the resources for all the participants. But thank you so much for spending the time to do that for everyone.
Okay. Yeah. Thank you very much. Take care. Bye-bye.
Awesome. Well, I will see everyone. Thanks for joining this morning. Again, any questions, just throw them in the Discord server and look out for more workshops upcoming. I know that Polkadot has a technical deep dive on the 8th of August, which we have announced, but anything that pops up, feel free to go to the Discord server. And thank you everyone for joining us on this Monday morning.
Thank you. Bye-bye.
Take care, everyone.